Hey guys, this is Mrs. Rooker. Go ahead and pause the video and do problems 1, 2, and 3, and then I will put the solutions up there. Here are your solutions. For number 1, inverse cosine of 1/2 is going to be pi over 3 because cosine of pi over 3 equals 1/2. And then inverse sine of 1/2 is going to be pi over 6 because sine of pi over 6 equals 1/2. And then we add those two together. We need to get common denominators, so this will be 2/6 plus 1/6 equals 3 over 6, which reduces to 1 over 2. So we have 1 over 2 pi, or pi over 2. All right, the next one, I'm going to start, I always start on the inside, so I'm going to start here with inverse sine of 1. So let's draw a unit circle. If we have sine is equal to 1, that's going to be at this coordinate point 0, 1. So that's going to be pi over 2. Now we do cosine of pi over 2. Cosine of pi over 2 is 0. So this whole first thing just became 0. And then I need to add whatever cosine of 0 is. Well, cosine of 0, this is the point 1, 0. So cosine of 0 is 1. So we just add 0 and 1, and that's how we get 1. And then the very last one, tangent of x equals -1. So tangent of something equals -1. Well, I know tangent of pi over 4 equals 1. So it must be negative pi over 4 for x in order to equal -1, since it's got to be in the the first or fourth quadrant. So x is pi over 4, and then we need to take secant of pi over 4. Well, secant of, secant is the reciprocal of cosine. We know cosine of negative pi over 4 is going to be root 2 over 2, or negative root 2 over 2. But we're going to do the reciprocal of that. So 2 over root 2, and then rationalize the denominator. So 2 root 2 over 2, the 2's cancel, we're left with just root 2. So today we are going to rewrite trig expressions using SOHCAHTOA and Pythagorean theorem, describe the domain and range of inverse graphs, and use inverse trig functions. So we're going to rewrite each expression for an algebraic expression of x, or as an algebraic expression of x, assume x is positive. So we are going to set this up using a triangle, and I'm just going to have theta be this angle in the lower left-hand corner for each of these. And I'm going to start with what's inside the parentheses. So we have inverse cosine of x. Well, I know that cosine is adjacent over hypotenuse. So I'm going to express this, what I have here, on my triangle. But I want a fraction, since I want adjacent over hypotenuse. So I'm going to change x into a fraction. To make x a fraction, I just put it over 1. So we have x over 1. So adjacent would be x, and the hypotenuse would be 1. So what's adjacent to the x? Adjacent is x, and the hypotenuse is 1. Then what we need to do is try and find the remaining side, because we're going to try and find sine on this triangle, sine of theta. So I'm going to use Pythagorean theorem now to find this missing side. I'm just going to call this b for now. So I'm going to do x squared plus b squared equals 1 squared. So that's Pythagorean theorem. Then I'm going to solve for what b would be. Subtract x squared b squared equals 1 minus x squared, because 1 squared is just 1. And then the final step is to square root both sides. So b equals square root of 1 minus x squared. So I don't need this to be b anymore. I will call this square root of 1 minus x squared. The whole point of that was now we can find sine. Sine of theta is going to be opposite over hypotenuse. So opposite of theta is root 1 minus x squared, and then hypotenuse is 1. But you don't need to write over 1. So this will be our answer for sine of theta. All right, moving on. We'll do the same kind of process on the next one, except now we're starting with the inside. Now we're starting with sine. So sine is opposite over hypotenuse. I'm going to put theta in this lower left-hand corner again. Now we're saying opposite is x, and the hypotenuse is 3, because this fraction says x over 3. Opposite over hypotenuse. And then we're supposed to be finding cosecant on this one. Now remember, cosecant is just the reciprocal of sine, so cosecant is hypotenuse over opposite. I have the hypotenuse, that's 3. I have the opposite, that's x. So I don't even need to find this other side, which is really nice. I don't need to use Pythagorean theorem. I just do that cosecant of theta is going to equal hypotenuse 3 over opposite x. And then I am good to go. Next one. Now I'm dealing with cosine first. Cosine is adjacent over hypotenuse. And I'm going to need to write this as a fraction, so I'm going to put it over 1. It's always going to be a fraction. So the adjacent is going to be 3x, and then the hypotenuse is 1. And what I need to find is sine. Sine is opposite over hypotenuse, so I will need this opposite side. So I'm going to use Pythagorean theorem to find that opposite side again. So I can call this one a squared, so 3x squared, plus, I'll call this b, so b squared equals c squared, so 1 squared, which is just 1. And then use Pythagorean theorem to solve this, or to solve for b. I'm just going to square this whole thing here. 3 squared is 9. X squared plus b squared equals 1. Subtract the 9x squared, and we have b squared equals 1 minus 9x squared, and then square root both sides to solve for b. So b is going to be square root of 1 minus 9x squared. And that should be helpful because we need to write sine of theta. So sine of theta is opposite over hypotenuse. So opposite of theta is this, and hypotenuse is this. So opposite is 1 minus 9x squared. And then over hypotenuse, which is 1, we don't need to write that. So this is our final answer. Alright, and then just one more in this section. This one's a little trickier. We're going to have some rationalizing of the denominators that you'll have to do, but if you want to, for a little challenge, pause the video and try this one on your own, and then you can unpause and I'll just work this one out. All right, so we're starting with tangent. Tangent is opposite over adjacent, and we need this to be a fraction. So we have theta, we have opposite over adjacent. So opposite must be x, and adjacent must be 1. And then we're going to try to find cosine. Cosine is adjacent over hypotenuse, so we will need to know what the hypotenuse is. So we'll find that now. We'll do x squared plus 1 squared equals c squared, the hypotenuse. And then to solve for c squared, we're just going to square root both sides. So c is going to equal the square root of x squared plus 1. And then we're going to do cosine. Adjacent over hypotenuse. So adjacent is 1 over hypotenuse, which is root x squared plus 1. But here's the tricky part. We can't leave our answer like this because we can't have a radical on the bottom. So we rationalize by multiplying top and bottom by x squared plus 1. We end up getting an answer of root x squared plus 1 over, the roots cancel on the bottom, we're left with x squared plus 1. And that's our answer for cosine of theta. All right, next section, label each one as inverse sine, inverse cosine, or inverse tangent. Write the domain and range for each. We did this before, so this will be a good reference. Since we did this before, if you want to pause the video and try to figure out which one's which on your own, that would be great. And then you can unpause the video and I will talk about each of them. All right, so this first one should be inverse sine. And I know that because it goes through the origin, because sine of 0 is 0. And then domain is how far left and right it goes. It goes to -1 on the left, +1 on the right. So the domain is from -1 to +1, inclusive. And then the range is how high up and down it goes. Well, the lowest possible point here is -1/2 pi, which is the same as -pi/2. And then it goes all the way up to here, which is +1/2 pi, or +pi/2. And it does include those points. All right, our next one over here is going to be cosine, because it does not go through the origin. So cosine, or inverse cosine of x for that one. And then same deal, domain is how far left and right it goes. This is how far left it goes, that's -1. And it goes all the way to 1 on the right. So -1 to 1. And then range is how high up and down it goes. The lowest possible point down here is 0. And then it goes all the way up to pi. Remember your principal values for inverse cosine are in quadrants 1 and 2, from 0 to pi. All right, and then that means the last one must be inverse tangent. The domain is that it goes forever to the left and forever to the right. So it must be -infinity to +infinity, or all real numbers. And the range is that it goes from -pi/2 to +pi/2. But remember, I don't have brackets for this one, those are parentheses, because -pi/2 and +pi/2 are not included because of the fact that tangent doesn't exist at those points. We're going to find the domain and range of each trig expression by using the above inverse graphs as a guide. So this one, I'm going to start with domain. And for domain, it's how far left and right the graph goes. So I'm just going to start with inverse sine, and I'm going to look at that graph. So inverse sine is this graph, and we're talking about the domain, so how far left and right it goes. Well, that's from -1 to +1. And then the other part is cosine. Well, cosine, you remember from earlier this unit, is a wave that goes on forever left and forever right. So there's no limitations on cosine. So I'm just going to focus on the inverse sine, which had a domain of -1 to +1. So whichever one's more limiting, we'll go with that one. Finding the range is a little trickier, but again, I'm just going to start with sine, and I'm going to think about the principal values for sine and which quadrant sine exists in, or inverse sine exists in, and that's, remember, in quadrant 1 and in quadrant 4. So in these two quadrants, and I'm going to think about my unit circle and what angles are at each of those points. So this is angle 0, this is pi over 2, and this is -pi over 2. And I know that range is, think back to algebra, range is what possible y values we have. So the x values that we are allowed to plug in is the domain, and the possible y values that we can get out are the range. So we know that for inverse sine, we can have solutions that are between positive pi over 2 and -pi over 2. And then those answers will get plugged into cosine, since inverse sine was inside cosine here. So we can plug in values anywhere from -pi over 2 to +pi over 2. So I'm going to plug in those options and see what answers I can possibly get out for y. So I'm going to plug in, I'm just going to start with -pi over 2. Cosine of -pi over 2. If I plug in cosine of -pi over 2, I get 0. So I know that 0 is a possible answer that could work for y. And then I'm also going to plug in, let's say I'm going to plug in 0, because I know that 0 is a possible value that I could get out for inverse sine. So I'm going to do cosine, so that was supposed to be in parentheses, cosine of 0. Well, cosine of 0 is 1, so I know 1's a possible value that I could get out as an answer for y. And I'm also going to plug in cosine of +pi over 2. Well, cosine of +pi over 2 is just going to be 0 again. So when I went through basically all of my options here, the lowest possible answer was 0 and the highest possible was 1. So my range is going to be from 0 to 1. All right. Let's move on to the next one and do that same exact thing. So for domain, it's a little easier. We can just look at the graph and see how far left and right it's going. So we're going to look at the graph of inverse cosine. It goes from -1 to +1. So that's our domain. Because sine just goes on forever. Well, that's a really ugly sine wave, but you get the idea. So there's no limitations on sine, so we're just going off of the cosine graph. All right, and now let's find the range. So our answer that we can get out for inverse cosine will be anywhere from 0 to pi. I'm also going to include pi over 2 in here because I want to plug in basically a good range of possible values. So those are all answers. Those are all the possible answers from here, from 0 to pi, that we could get out when we do inverse cosine. And then those are values that could get plugged in for sine, since this is all inside of sine here. So I'm just going to plug in those options and see what I get out for my y. So y equals sine of 0. Well, sine of 0 equals 0. So 0 is a possible answer that we got out. Now let's also do y equals sine of, let's do pi over 2. Well, sine of pi over 2 is 1. Okay. And then let's also do sine of pi. Well, sine of pi is also 0. So everything that we get out is going to be something between 0 and 1, so that's going to be our range. You're never going to get a -1 or anything below that. All right, and then the last one is actually an easier one because we have here the inverse tangent inside of tangent. You might remember from the other video that I said if the inverse is inside, you are good to go to cancel these out. It doesn't matter what this value is. If the inverse is inside, you're good to go to cancel them. So all that's left is y equals x, which, if you remember, is just a line that goes through the origin. That's y equals x. The domain of a line is all real numbers, so -infinity to +infinity. And the range is also all real numbers, -infinity to +infinity. We're just going to do a little practice here, simplifying the expressions without a calculator. So if you'd like, if you feel kind of good about this, you can pause the video and try to simplify this. Otherwise, you can watch me do this one. So we're going to start by doing sine of 0. Well, think back to last unit. Sine of 0 is 0. But now we're switching to, actually I'm going to make this a little lower. Okay, now the next one we're doing inverse cosine. So I'm going to rewrite this as cosine of some angle theta equals 1. So think of what angles would give you a cosine of 1. Well, that's 0. Then tangent of 0, just like sine of 0, is 0. So this is just going to be 2 times 0. So that's going to be another 0. And then our very last one is going to be minus inverse cosine of 1/2. So we'll call this cosine of some angle theta equals 1/2. Cosine of what angle gives you 1/2? Think back to your unit circle. Think about that for a second. That answer is going to be pi over 3. And then we have this negative here, so don't forget that there should be a minus there. So 0 plus 0 plus 0 minus pi over 3 is pi over 3, or negative pi over 3. All right, and then the next one, we're going to always start on the inside. It's a little more challenging, so we're going to want to draw a picture, just like we did earlier today. And I'm going to draw a triangle, and these are both positive, 8 and 7, so it's going to be in the first quadrant. So remember, tangent is opposite over adjacent. So my opposite is going to be 8. So this is 8. And my adjacent is going to be 7. Right? And this would be theta. Right? What I don't yet know is my hypotenuse, and I will need to know the hypotenuse in order to find cosine, because cosine is adjacent over hypotenuse. So I'm going to use Pythagorean theorem. 8 squared plus 7 squared equals c squared. 8 squared is 64, plus 7 squared, is 49, equals c